Welcome to KSR Datavizon. After learning the essentials of data science, a lot of data science aspirants wish to get real-time experience by doing projects, but do not know what to do or how to start. Unfortunately, there are not many resources available online which can give real-time exposure to students. So, we at KSR Datavizon are making an effort to help students understand the nuances of data science like PDA, pre-processing, drawing insights, model building, validation, etc. So, we sincerely hope that this project clears all the confusion that you people have and also helps you in understanding the real world. So, in this video, we'll do churn analysis using telecom data. This is real-time data, and if you want to practice on the same data and probably put it in your resume as well, then please reach out to us. We'll mail you the actual data. Okay. So let's dive into the project. So I'm using Jupyter for this particular project. So let us import pandas and NumPy. So we'll be using both these packages very frequently. So let me import both these packages, and also let me import the data. Okay. So let me import the data as well. So friends, the first step that I am doing after importing the data is I'm checking the shape of the data. So shape. So what does it actually tells us? It gives us this basically tells us that there are about 35,000 rows and about 11 columns. So let me do some sort of PDA to understand my data. So df.info. So what does this tells us? So these are the columns that we have: segment, billing class, site billing status, consumption, all these things: value, unbilled, billing frequency, unbilled data, unbilled days, root cause, voice attempt, target. And target is our target column. And then also there are 35,375 rows. So here you can see that there are couple of nulls, few nulls in unbilled days, and there are a lot of nulls in voice attempt. And then there are object and float 64 and int as well. So this is pretty clear that we have combination of both numerical and categorical columns in our data. So let us understand a little more about the data. So let me do head. So here this will give us the sample rows, the first 5 rows. So segment consists of others, mostly others. You can see that, and billing class, small and medium enterprise, and I don't see anything else. Same goes for site billing status as well. We have live, build, and stock. Clean for site status, consumption value. Okay, here there are a few zeros as well, and then mostly it is in thousands, and value unbilled it is in hundreds. Okay, different scales. Billing frequency is Q. Q actually stands for quarterly. And unbilled days. Unbilled days is the number of days it has passed after the last bill date. So root cause, no root cause match. And voice attempt, I can see that there are a lot of nulls. This is something that we have learned it from here as well. There are a lot of nulls in this particular data. And then target, it consists of zeros. So let me look at tail as well. So here again segment consists of others only, and billing class, it's small and medium enterprise all the way. And site billing status, we do have not assigned. So we have other values other than live, build, and stock. Status is dirty and clean again. So here consumption, the value is not only in thousands, it is in hundreds as well, and there are a lot of zeros actually. So value unbilled, it is in probably hundreds with different scales, and billing frequency is monthly as well, not only quarterly. Unbilled days, okay, this is less than probably 200. Then root cause, there are different values for root cause, voice attempt, mostly null, and target of 0. So let me pick up random values. Let me do sample of 5 to understand data in much more depth. So here, okay, finally we got some other value for segment. So small enterprise. And then this is how the data is. More or less everything is same that what we have already observed, except in root cause, where so we have different actual reasons for the root cause. Okay, so voice attempt. Okay, finally we got at least one value which is not null. Okay, so this is the data, guys. So we understood the data. So we understood the sample rows and what sort of values are it is taking and everything. So now let's see how many null values, how many missing values are there in each column. So for that, let me do ds is null dot sum. Okay. So here we can see that unbuilt actually has 300 missing values and voice attempt. Okay, lot of missing values. So let me do the same thing. Let me uh, try to get the missing values expressed in terms of percentage. So here, okay, I want it in terms of percentage. Let me just say multiply by 100 and I want to round it off to two decimal places. So here, sorry guys, this should be df dot shape of 0. I want to divide by the number of rows. So yeah, here you can see that it is less than 1%. Okay, build days, and it is a numerical value, and number of missing values is less than 1%. And voice attempt, almost 98% of this particular value is null. So probably if you have learned it, you have already learned that if the number of missing values is less than 10% or 5%, impute with median. If it is more than 50 or 60%, delete it. So let us understand whether whatever we learned so far is correct in every scenario or not using this particular data. Okay. Now I understood missing values. So only two columns has missing values. Rest all the data is clean. So let me understand the data in much more depth. So here, consumption, value, unbilled days, and target. Whenever we do describe, it only describes numerical values. So we have only four numerical or continuous columns, only for consumption, value, unbilled days, and target. But here you can see that it is expressed in terms of E, something like E, which I don't want. I want absolute number. So what I'll do is, I'll say pd dot my set option, okay, set option, and I'll say display dot float format. Display float format, and I'll say lambda x. Okay, I want to display, okay, as a float, not actually as an integer, because here there are few float values as well, like 0.7, 0.7, etc. Not everything is an integer, there are float values as well. So let me just say 2f, which is the percentage 2f and percentage x. So what it does is it will remove everything that is exponential, expressed as exponential. So if I run it again, so here you can see the values as absolute numbers. The values as absolute numbers instead of e. So now let us understand the data much more in depth. We will describe. So here is the mean. The mean is pretty huge, 24,000, unlike what we have actually seen. So here the median is 3,000, and then if you compare, mean, median, and then the max and 75th percentile, we can clearly see that there are outliers in this structured data. And here in unbuilt days, we've already seen that there are missing values. And then in unbuilt also, there are outliers. In value unbuilt also, there are outliers. So it is pretty clear. Our median and mean, there's huge difference. Also, here also, there is huge difference, almost double, more than double. And then our 76 percentile and max value, also there is a huge gap actually. And target value, here we have zeros and ones. That is something that we already understood. So this is something that we understood already. Okay, so there are the point that we can take off from this particular table is that there are missing values which you already observed, but there are outliers in all three columns: consumption, value, unbilled, and unbilled days. So apart from missing value imputation, we also have to take care of outliers as well. So okay, fine. So first thing, what should we do now? So let us understand there are a lot of zeros in consumption. Let us understand how many zeros are there in consumption. So for that, I'll say consumption dot. So we always see there are no missing values. So I'll say equals to 0, and how many values are there which are equals to 0. So let me check. So there are 9,493 values which are zeros in consumption. Okay, let me check the same for value unbilled as well. So here there are 645. Okay, manageable at least. So, but for Unwield, the days, the minimum value itself is one. Minimum value itself is one. So we need not check this particular value, like whether any values are, how many values are zero or not in particular column, because the minimum itself is one here. So there are no zeros. Okay. So now I want to check the distribution. So we understood, like, there are outliers in the on all the three columns. So I want to check the distribution. So how do we check the distribution? Let me import matplotlib for that. Matplotlib.pyplot as plt. Let me run it. Okay, it is running. Yeah, okay, it has run. So let me go back. So now I want to plot consumption and value unbilled and unbilled days, and I want to check the distribution. So how do we check it? I'll use histogram for that. I'll use histogram. So let me check it for consumption first. Okay. So here you can see that. Okay. So we have one more challenge here. These values are expressed as E. So whatever we have set it for, right? Pandas, it works only for pandas data frame, not for matplotlib. So for matplotlib, if we get anything like this, so what should we do? We simply have to add one more line here saying my label, my tick label format. I don't want E or anything. I want it to be plain. So I'll say my style is plain. So here you can actually see, okay, there is one more problem here because they are overlapping. So I want to rotate the axis. How do I do it? Plot dot x6. I want to rotate my x-axis. So I'll say x6 and I'll say rotation. Sorry, not this. My rotation, it's not there, it's not coming. So let me just rotate by 45 degrees. Okay, here you can see. If I don't want all this text and array, I can simply say like a something equals to this. So okay, fine. So because of x6 and everything, I'm getting these ones. So here you can see that a lot of values are between 0 and probably this is 25,000 or something. So between all these values, more than almost 100% of my values, almost these values are falling between this particular bucket, and there are less than 1%. We almost cannot see the number of points lying here. So let me just check quickly for unbilled days and value unbilled as well. So let me just say plt.hist, and then let me quickly check it out for unbilled days as well. So here also, okay, it is a little better. So let me check it for the value unbilled as well. Okay, this is also more or less same. So in all the cases, there are a lot of outliers and the distribution is completely skewed. They are not normally distributed. So, okay, we understood that. So what the outcome of this particular exercise is that we cannot use mean. We cannot use mean because there are a lot of outliers. We cannot use mean to impute values. So be it outlier or missing values imputation, we cannot use mean. So let us quickly do missing value imputation for unbilled days. So again, let's check how many missing values are there quickly. Okay. So there are 300 values. So let me quickly do it using missing value imputation using median. So unbilled days dot median. This will actually give the median value. This will give the median value for us, and I want to do replace here itself. I don't want to create new variable. I want to do it in the same variable. So if I run this particular command again, so here you can see that I've replaced everything. There are no null values. I've replaced all my missing values using median. Okay, missing values are taken care of. Now, how about outliers? So let me write a small function for outlier treatment. So this particular function will take my series as input because there are outliers in all three columns which we have seen. In all three columns we have outliers. So let me write a function so that we can use the same function to replace everything. So here I'm using IQR method And I want to calculate median as well. So series dot median. This will give me median, and I want to calculate lower hinge as well. So my lower hinge is 25th 25th percentile, and similarly my upper hinge is 75th percentile, and then IQR. What is my IQR? It is upper hinge minus lower hinge. Okay. Then I want to calculate my upper limit and lower limit as well. My upper limit is, so this is something that you would have already learned if you have taken any course. Otherwise, please refer what is IQR for outliers. So explaining what is what is IQR and what are the other methods that we have for outlier treatment is completely out of scope for this particular video. So yeah, I'll calculate everything. And also here you can see that where is described. Yeah, here it is. You can see that my minimum value is 0, 0, and 1. So there are no outliers on the other side of the spectrum. So there are only outliers only on one side, on one axis only. So let me do it. Let me cap my outliers. So how do we cap it? I'll say np.where if my series is greater than upper limit. If my series is greater than upper limit, then replace it with upper limit and capping it. If not, let my series be as it is. And then I want to return the series. Return series. Sorry, there is a spelling mistake. Yeah. So if I have outliers on both sides, then I would do something like my series. If it is less than my lower limit, if it is less than my lower limit, I'll say, okay, replace it with lower limit. Otherwise, let my series be as it is. So this is how I'll do outlier. But as because there are no outliers on lower side, so let me comment it out. Okay. So now I want to use this particular function to treat my outliers. So the method that I have used is IQR, and I'm capping it instead of replacing it with median or mean or anything like that. I'm actually capping it. So using IQR method. So whenever the values are greater than 1.5 times of my IQR, 75th percentile plus 1.5 times of IQR, all those values which are greater than this particular value, I'm capping it to this particular value. So this is what I'm doing here. Yeah. So let me quickly do it for the other two as well. So there are my unbilled days, my consumption, and value unbilled. So these are the three numerical columns that I have, and target is our target value, which has only zeros and ones. Okay, now I have done it. So let me do describe again after creating outliers. So here you can see that there is not much difference between 75 and max. So these are acceptable values. And how about see here difference actually appears a little huge, but difference is not so huge in reality, because if you look at 50 to 76 percentile, the difference is about 100, and here it is about 150. So that is acceptable. So here also it is 500, and here it is a little over 1000. So this is acceptable. Otherwise, we can actually, in fact, we can replace everything with median as well. But for us, this is actually good, because we don't want everything, every value which is if consumption is very high, I don't want it to be part of, I don't want to replace it with median, because it will fall all those values which are actually all these values, I'm saying they are median, so I'm putting it somewhere here, so which is something that I don't want. Here you can actually see, so everything which is more than 2000 or more than 1500, what the value is, I want to cap it everything. I want to say everything which is greater than 1500. I'm saying everything is 1500. So that is much more acceptable to me rather than saying everything which is more than 1500 to be 500. So yeah, this is outlier. So let us quickly draw the graph as well. So let me copy paste it here. Okay, here this is my value. Okay, so here we can see that there are after capping outliers, I can actually see some graphs. So this is still not normally distributed, but okay. So I have created my outlier. So let me quickly do the same thing for the other two as well. So let us check the distribution after outlier treatment. Okay, so this is good. And then for value unbuilt. Okay, value unbuilt also, this is pretty good. But they are still not normally distributed. So how do we make it normally distributed? So normal distribution actually is required when we are doing logistic regression or any of gradient descent algorithm. If we are going for tree-based algorithm like decision tree, random forest, then we need not actually do any we need not normalize the data. But if you are planning to use logistic regression or neural network which runs on gradient descent, then we have to normalize the data. So let us try to normalize the data. And how do we normalize the data? Let me quickly. There are different methods actually. So we can use normalize from sklearn package, or we have we can do a log normal, or we can do square root and everything. So let me just quickly do it using box plot. So let me import box plot, ipy.stats, and I want to import box cost, box cox. Okay, I've run it. Okay, here we are. So I want to first check. I want to check log normal distribution before. So let me just do df of consumption. Why is it not coming? Okay, df of consumption. Okay, so I want to use box plot, box cox transformation, and I want to use log normal. So I'll say df of consumption again. Something is wrong, right? I think this has run, so I don't know why my sessions are not coming with that. Okay, finally it came. Okay, yeah. And then if I put zero here, sorry, if I put zero here, I'm doing log transformation. We got an error here. Data must be positive. Okay, we are seeing that our value actually where is this right here? Yeah, we have seen that my minimum value is zero, and if you do any log transformation on zero, it gives an error. So that is the reason it said there should not be any zeros or negative values. It should only be positive. So let me just do 0.001. Okay, here we are, df of consumption. So let me just quickly plot my consumption value after doing normalization. Okay, probably I should have given a different name here. Okay, so here it is. So let me quickly make it norm because I don't want to touch df consumption because we already changed the value. If I want to do anything else, then it's always doing. So I should have actually given a different name. So let me quickly run everything from first. I say restart and run all. Probably it will take about 30 to 30 seconds to 60 seconds. Okay, let me pass my video. Okay, friends, we're back. So this is how the log normal function after applying logarithm to try to make it normal distribution. This is how the graph is. Still, it is not normal. So let me apply square root. So how do we apply square root? This 0.5. Okay. So for 0.5, okay, it is acceptable for me. Let me just check. Minus 0.5, which is basically square. So here, okay, and then let me do minus 1 as well. So for box plot, okay. So of all, we can actually try minus 2 plus 2 as well, but I think 0.5, which is square root, actually holds good. So for square root, I think this is good enough for me. This is quite normal distributed with long tails, okay. So there are a lot of zeros. So this is something that we can't do much about. So if you still want to be much more normally distributed, you can do it again. You can do square root again, which will be fourth root of our consumption. So that will give much more normally distributed. So let me do the same thing for my value unbuilt as well. Value unbuilt, yeah. Okay, and I want to plot it as well. So let me just say, and then I want to plot the normalized one. I want to see how it looks like after normalization. Okay, guys, so a little normally distributed, much better than how it was before. So let me do the same thing for unbuilt days as well. Yeah, here is my unbuilt days. I'll say unbuilt norm. So okay, guys. So here, this is much better actually. Unbuilt days is much better. So I've normalized all three. But still, like, is my pre-processing complete? I would say no. The reason is, look at the scale. It is 0 to 40, fine. It is 0 to 80. Okay, more or less on the same scale. But here it is 0 to 400. So it is 0 to 400 after taking square root. So they are not on the same scale. So gradient descent doesn't perform as expected if the values are different scales. So for that, what I'll do is I'll try to bring everything into same scale. So how will I do it? There are different scales available. So like standard scalar, min-max scalar, etc. So for this particular exercise, let me use min-max scalar. And in which package do we have min-max scalar? It is sklearn dot preprocessing. Okay, import. I want to import min-max scalar. Yeah, let me run it. Okay, here we are. Let me just say min-max scalar equals to min-max scalar. Okay, and I want to use the same scalar for all three, like consumption, value, unbuilt, and what is the other one? Unbuilt. For all three, I want to use same min-max scalar. So I will say okay, and I want to apply it on my normal distributed data, not on the raw data. So I will say consumption norm. So let me give me a second here. Let me add few cells here. Okay, fine. So let me say df of columns. So here, these are my three: consumption, norm, everything. Okay. Okay, and I want to apply min-max scalar on all three. So I'll say something like MMS min-max scalar. Here is the way I define my object, and I'll say fit transform. I'll just fit. Where is my transform? Yeah, fit underscore transform, and I want to do the same thing. And I want to give new names to it. Like instead of norm, I want to say scaled. Because if I feel like this it's not good, then I want my original values to be retained. So that is the reason I'm giving new value. Okay, guys, the new values are actually defined here. So you can see that three more values got added. Let me do describe quickly. So df of describe. So here you can see all six values that I have created, like consumption normalized one, and then value unbuilt date, and then these values which are between zeros and one, between zeros and one, all three. So everything is in same scale and everything is normally distributed for me, more or less normally distributed for me. So let me quickly, okay. So let me quickly plot all these things as well after applying normal like scaling. So scaling doesn't actually change the structure. So here the structure doesn't change. Only okay. So it's not norm. It's actually scaled. The structure doesn't change. Only the values change. So the same goes for the other two as well. Unbuilt is scale. Okay, fine. Is good. And then okay, everything is between 0 and 1. All scale is same. And then everything is more or less normally distributed for me. And there are no outliers and there are no missing values as well. So this concludes my EDA and pre-processing for what? For numerical variables. For numerical variables, I have done the pre-processing and EDA as well. So if I want to look at insights, if I want to draw insights, then how do I do it? So insights are something that we will say, okay, we'll present it to the client saying, if this is a scenario, we are talking about churn analysis, guys. Remember that we are talking about churn analysis. That is, a particular company will leave our company if we don't, if if these are the scenarios that are met. So these are called as insights. So let me quickly do insights again. So before that, let me check the value. Okay, we have everything here. So let me quickly do head of two. Okay, what I'm interested in is in column names rather than anything. Okay, so now I want to say df of consumption. How is my consumption behaving when my target is zero? When my target is zero, how is my consumption behaving? So for that, I'll say my target equals to zero. My consumption dot describe. Or let me just remove my consumption as well. So it will give values for everything. Or if I want to see only for these three values, I can do that one as well. So let me quickly copy it. Okay. Yeah, here we are. So when my target is zero, that means when there is no churn, these are the values. And how is it varying when my target is one? When my target is one, these were the values are. So here, this is what I want to check actually. So when if my target is zero, the consumption is on an average the consumption is 9,700. But for the churn customers, the consumption is pretty high. Consumption is pretty high. When it comes to unbilled, not much of difference. When it comes to value unbilled, there is some sort of difference actually. So one of the insight that I can draw is unbilled days. There is not much of difference, so I won't show it to the client. But for consumption and value unbilled, if I want to put a threshold, if consumption is more than a certain limit, if the consumption is more than this, there are higher chances that my customer will churn. Chances are higher. So that is how I'll put it. If my consumption is more, same goes for value unbilled. So both combination of if my value unbilled is also more and my consumption is also more, my customers are looking to churn now. So this is the answer that I want to give. So probably what the real case scenario is that value unbilled days, the value unbilled days I have already explained. The number of days post which the number of days before which my last bill date was there. So when was my last bill date? So the number of days after my last bill date is unbilled date. And what is the value after my last billing? What is the value that is still to be billed? So that is my unbilled days. And what is the consumption? Consumption is how much data I have consumed after my last bill. So these two values. So if a particular company wants to churn, if wants to leave, so then what is happening is they're using pretty high value, and then they're using the consumption is pretty high, and the value unbilled is also pretty high, and they are not actually paying. So probably the reasons could be they on an average the value unbilled usually they'll be paying around $500 or $600, but this time the value is much more, so $1,200 or $1,300. So they don't want to pay, thinking something is wrong with the company, so they want to churn. They want to just move out of our company. So this could be the possible reason. So what can the company do? In these cases, my telecom company do is whenever the particular value unbilled goes above a threshold, we have to say intimate them saying the value unbilled usually it is $600 for you, but here this time it is $800. So maybe there is a gap. You want to actually rectify. So this is something that we can do. So these are the insights. Okay, guys. So this is the particular insight that we have actually drawn from this particular data from numerical columns. So we are yet to analyze our categorical columns. So let's do the same thing. Let's analyze categorical columns as well. So how do we do that? So let me just say describe. describe, and I'll say include equals to O. So this will summarize my data for all the categorical columns, for all my categorical columns. Okay, and one thing that we have actually forgot is how is my target behaving. So my target, and then I'll say value count. Let's get back to target again. So let us finish the analyzing summary for categorical columns. So here segment, my top value is others, and there are only 5 unique values. So the number of unique values across is very less, like 2, 3, 5, 10, 4, etc. Very less. So it is actually quite good for us to do, analyze each and every column. And then the top value is others here, and the frequency is mind blowing. So almost 90% of my data is others, only others for segment. For billing class, okay, the frequency is much higher. So small and medium enterprise is what comprises almost like 90, I would say 99% of my data. But side billing status also, more than 90% of my data is single value. For dirty, okay, probably 60% of my data. Billing frequencies we have already seen quarterly and monthly. So quarterly, okay, the frequency is almost like 80%. This is I would say 50%, and then voice call done. And remember, guys, there are a lot of missing values in the voice attempt. So what should we do? How do we deal with missing values here? So more than 90%, 98% of our data is missing. So should we just drop it or not? So we'll analyze and we'll take it. So before analyzing the category columns, let us understand our dependent variable as well. So this is something that we should have done much earlier. Okay. But anyways, okay. So this is my target value. There are 33,000, almost 90 to 95% of my values is zero, which are existing customers, and one says churn customers, 16. So I want to express the same in terms of percentage as well. So how do we do it? I'll say from this percentage, so multiply 100 and ds dot shape of zero, sorry, 0, and I want to count up to 2 decimal places. Okay, almost 95% of my data is good, but only 4%, 4.8%, less than 5% of my data actually has ones. So this is called as unbalanced data. So our data is clearly unbalanced here. So how do we go about it? So we'll look at it when we'll come to model building. So here my data is completely unbalanced. Okay. So now let us try to understand each and every column in detail. So the first is segment. What let me say value count. Okay, here we have 5 values: other, small enterprise, medium enterprise, and here the guys you can see that medium enterprise the value is the same. They are actually same, but there is spelling mistake in medium enterprise. So let us correct it. So this is something that's part of pre-processing as well. All spelling mistakes or whenever we change the data from one system to another, one source system to another, or one database to another, all these problems happen. So let me rectify it. So if I say if my segment value equals to medium enterprise, if this is medium enterprise, then I want to say no, correct it to medium enterprise with correct spelling with an E at the end. Alright, let my segment remain the same. Okay, and here if I do value counts again, so you can see that my medium enterprise earlier there were 9 values, and here it was 400. That got rectified. Okay, medium segment. So almost there are only 4 values: other, small enterprise, medium, segment, TBA. I don't know what this actually stands for. But again, okay, most of more than 90% of my data is others. Okay, so let me do the same for my building class as well. So I want to understand building class. I want to understand all my columns. So let me do value count here. Okay, this is quite simple and quite straightforward. So let me do the same for the other columns as well. So site billing status. Okay, this is also like not assigned. We can take it as a null value, or we can keep it as it is, not assigned. And then okay, copy this one. After site billing status, we have site status. Okay. Here also we have some value like not assigned and not A. Not A actually stands for not assigned, most probably. So let me correct the same as well. So let me use the same formula that I've used here to correct segment. Let me use the same thing to correct my site status as well. So if my site status is not A, if it is not A, make it not assigned. So that's what I'm doing it here. I'm cleaning my data. And data is in real world, this is how the data will be much messier. We have took a sample of the data, so that's the reason we are not seeing all the values. But in the actual data, which consists of millions of rows, the data is much more dirty actually. So here, so I've already done that, and the next one is billing frequency. Okay, we have billing frequency, root cause, and voice attempt. So let me do billing frequency. Okay, it is quarterly and monthly, fair enough. And then let me do root cause as well. So here, no root cause match, impossible, and I don't know what this is. Outsort, EMMA, business exception. So data looks clean actually. There is no need to clean the data. Data is actually clean for us. And the last column is voice attempt. Voice attempt. Here it is voice call done, voice second attempt, voice call request, voice first attempt, etc. So and this is a column where we had almost 98% of the values are missing. So guys, after looking at this one, I don't think we have to drop this particular column. This column looks to be very important for us. The reason is whenever if it is missing, that means there was no voice call attempt done. So there was no voice call attempt done. So whenever it is done, I'm sorry, whenever it is done, the data is captured. If the data is not captured, it means they have not attempted to make any voice call. So let me fill the value instead of dropping this particular column because we have 80% or more value. Let me fill the value using let me just say voice call not done. Voice call not done, and I want to replace in this particular column as itself. So let me do value counts again. So here I've replaced everything. Whichever is null, I've replaced it with voice call not done. Voice call not done. Okay, guys, we understood the data. We understood there are missing values and we have filled imputed missing values here. There are a lot of options that we have. Usually I could have actually said not assigned MA, or I could have deleted this particular column, but I did not delete it because I felt like this column might be useful because and it is actually reasonable to impute it with voice call not done. The reason is whenever the value is filled, they have actually reached out to us. So whenever they haven't reached out to us, there was no voice call done. So that is the reason it is null. So it is this is where the domain knowledge comes into the picture. Okay, guys, I've imputed my missing value. The next thing is I want to analyze each of these columns just the way I have done it here. So I want to analyze whenever it is zero, the churned customers and the current customers. How are these two behaving? I want to analyze these two. So, and how do we do that for category columns? We usually go for crosstab. Okay, crosstab of df of. Let me do it for voice attempt first. Voice attempt, and I'll say my target. I want to analyze these two together. So here, guys. So as expected, whenever there is a first attempt, the number of cases out of ten, almost only 40% are remaining. So whenever there is a customer who is actually calling us, 60% are leaving our company. Same goes for voice requested, a lot of them. So remember, guys, the number of churns, the data is completely imbalanced. Only 5% of our overall customers are leaving. But here you can say if they are doing first attempt, 40% or 60% are leaving. Here almost 40% are leaving. Here also more than 25% or 33% of them are leaving. Here also almost 70% of us are leaving. So whenever there is actual value, whenever they are calling us, they are leaving the company. They are leaving us. They are churning out. So only when there is no call done, it is in sync with the overall data. So this is very important insight that we can. So okay, we got this insight, but how do we present it to the client? So for that, we'll be using bar graph. So before that, let us try to get bar graph done. So let us express this particular thing in terms of percentages actually. So let me convert this particular information into a pandas data frame. So let me just say cross tab equals to pandas data frame, and then I want if we do that, guys, we'll have cross tab. Okay, okay. So this how it is, and I want to actually reset my index. So these are my index. I want to reset index. So let me do reset index. Okay. So this is my index, and then I can actually say give meaningful values, because whenever the values are zeros and ones, it is very difficult to perform pandas operations. So let me rename my columns equals to, let my voice attempt be voice attempt itself, and the zeros and ones, let me just say target 0 and the target 1. And this particular target is not actually a column, it is an index for us. So let us not bother much about it. So here we can see that this is my cross tab results. And what do I want to do? I want to express everything in terms of percentages, right? So that is what I want. So let me just say cross tab dot. Let me create a new column here. Let me just say sum. I'll say, sorry, I copied wrong word. So cross tab dot sum I want to do, and I want to sum row row wise. So I say sum axis equals to 1, and I want to keep values here. Okay. Yeah. So this warning is because of the difference between copying actually. So we have deep copy and shallow copy in Python. So how memory is managed. So that is the reason we got this error. Not error. This is a warning actually. So to remove this warning, we can simply say dot copy. So this will remove this particular warning. So that's fine. So it is saying with numeric only, this particular value is deprecated. Okay. So not much to worry about. So here is what we got, the values actually. Okay. So what I want to do is I want to convert this into just say percentages. I want to convert everything into percentages. I'll say a target of 0 equals to cross tab in quotation, target of 0 percentage. So and then I'll say cross tab of my sum. And I want to do the same thing for my target 1 as well. Okay. So after doing this, how is it? So okay, everything is expressed in terms of percentage. And now once it is done, I don't want this sum to be there. So we can actually drop these two. And I also want to convert this particular voice attempt into my index. So I'll say cross tab dot index equals to cross tab of voice attempt. Okay, I don't have it anywhere. Let me type it. Voice attempt. Once I convert into index, I want to drop this particular column. So I'll say drop and my sum as well. Okay, we are doing all these things so that. Okay, so let me quickly run cross tab again. Okay, okay. It should be 4, not 400. Okay, so what happened is they are running it quite a few times, so that is the reason we got it here. Okay, here we got it correctly this time. So 40, 600, everything. So okay, guys. So this is by looking at this data, we can clearly say that whenever there is an attempt made, to reach out to the customer care, the target value is pretty high, pretty huge. So only when no attempt was made to talk to us, customers are remaining with us. But if there is any attempt, there are some very high chances that people are actually leaving. The companies are actually leaving our company and going for separate vendor. So this one. So let me replicate everything, showcase everything in terms of graph. I'll say the bar graph. So even I just want to represent everything in terms of in a graph actually. Let me just say plot of bar. Okay. So here you can see that. Okay, let me just say rotation equals to 45. Okay. So I'm not using matplotlib here. I'm directly using the plot option available in pandas. So this way, from the graph also, it is pretty clear that whenever there is attempt made, then they are churning out. Whenever there is no attempt made, they are remaining with that attempt. So I want to do the same thing for all my columns. So that is the reason. Let me create a new function quickly. So I'll say cross tab plot, and I'll say df and my column. Df is our data frame and column. So let me copy paste everything that we have done here. Okay, our cross tab is not required, and then here. Okay, and finally I want to plot this as well. I want to plot this as well, and then I want to say, okay, this is not my voice attempt, this is column. Same goes for here as well. Everything is quite fine. Okay, guys, I've generalized it, so this should hopefully work for all the columns as well. So let me just quickly test it with voice attempt. So voice attempt, whether this particular function is running or not. Okay, we got an error. Here are some. Okay, we probably have missed this particular value. We can copy it. Okay. Okay, guys. So this function is working. We got the same graph both. So let me do the same thing for all the columns. Let me plot for all the columns. So let me just copy it. Let me just do columns, and then these are all my columns. Till okay, the rest are category columns. So let me just rest are numerical columns. Sorry. Let me just say my cat columns equals to and this here, and then here the consumption value unbuilt are numerical, so I'm removing it. Same goes for unbuilt as well. I'm removing all this. So let me bring everything in the same line. Okay. So these are my cat columns, and I want to run it for all columns. So I'll say my cat calls, and I want to do this for all my columns. Okay. So here, okay, fine. So this is for segment. For segment, okay, for others, okay, for medium enterprise, for segment TD and small enterprise, the chances of leaving are pretty high compared to others. For quarterly, for billing class, industrial, commercial, and small and medium enterprise, it's not so. So we can actually ignore it. Same goes for site billing status also. So whatever it is, so there is not much difference. There is a slight variation here, but not alarming, not so alarmingly high. Same goes for site status as well, and billing frequency also. And here, so whenever there is a technical exception, people are leaving. So mostly it means the internet is not working for them. Whenever there is such root cause, then they are leaving. And the voice admin is something that we have already done and looked at. So these are the insights there. This is what we are going to present it to the clients and explain to them, saying, okay, whenever customers reach out to us, with any problem, they are most likely to leave. So don't ignore their complaints. Never ignore this complaint. So this is one insight that you can draw. And especially if the root cause is technical exception, they are leaving. They are like leaving. Most of them are leaving. Almost like two-thirds of them are leaving. Only one-third are still continuing with us. So whenever there is a technical exception, go like beyond what you are actually doing. So if required, give 1 month of service for free. Otherwise, they are most likely to leave our company. So here again, so for whenever we can combine all these things. Whenever others are reaching out, it is still fine. But medium enterprise, segment TBR, small enterprise are reaching out with any problem, then they are most likely to leave us. So these are the insights that we can draw, and we can portray it to our customers. Okay, fine. So we have done a lot of the analysis and everything. So let us get back to model building. So let me quickly add few new skills here. So for model building, so uh, see for numerical values, what we have done is we have done missing value analysis, we have done outlier analysis, and it is of different scales. So we have brought everything under the same scale. For categorical values, missing value analysis is done. There won't be any outliers, so we have ignored outliers part. And there were some errors, or probably how would I put it? The data is not clean, so we have cleaned the data. The dirty data we have cleaned it, and similarly, then what else is required is we have all these values which we need to do one hot encoding. So that is what we are going to do next. So as part of pre-processing, for categorical variables, we are converting everything into one hot encoding. So let me create a new. So let me zoom in. Yeah, let me create a new data frame, and let me create dummies for it, which is one hot encoding. Pandas has get dummies function. So using this, I want to say, and I want to do it for all categorical columns. I want to do it for all categorical columns. So already let us separated everything categorical columns. So let me just do ahead once we do that. Okay, so here this is how the dummies work. It creates a new column for each value of categorical column. Categorical column for each value, it creates a new column. Okay, dummies is also done. I have to integrate this with my actual data. So let me create a new data frame. Let me call it df underscore full, and I want to concatenate these two. So let me say v.concat, and I want to concat my df, the original one, and then df underscore dummies, and I want to do it row wise. So let me just say x is equals to 1. And guys, when I'm doing these two, remember that my categorical columns are already there in this, and I'm converting everything to one hot. So after doing it, my categorical columns will still be there here. So let me just do shape. My shape is 46, and then like I have to remove my categorical columns from here. So or let me do one more thing. Categorical columns I've already defined. Let me define my numerical values as well. So let me replace my cat calls with this one. I'll say like columns. So I'm saying from now on, not these are not my categorical columns, but whatever the categorical columns that I have defined after doing one hot encoding, they are my categorical columns. So let me just say list because that comes as index. Okay, and my numerical columns. What are my numerical columns? They have only like few columns. We don't want consumption, we don't want value unbuilt, we want actually the scaled one. So these are our new numerical columns. Let me define my numerical columns as well. Fine, these are my numerical columns. And lastly, what is my target? My target is my target. Because these are the columns that we require. So rest of the columns are not required for us. So let me consider only these columns. So my new df full equals to df full of, I want my categorical columns plus I want my numerical columns plus I want my target. I don't want anything else. So if I look at the shape now, so I got only 33. So rest of the original columns like consumption, value unbuilt, segment, billing class, everything are removed. In fact, if you look at it, None of the original columns we have retained. None of the original columns are actually there. So all we have retained are the scaled ones. After removing outliers, imputing with missing values, converting into normal distribution, and then scaling the final one. And then for similarly for category columns also, the one hot encoded one after doing missing value imputation and cleaning the data. And finally, target one. Target will never touch the target column. So target remains as it is. So guys, this is our final data. So this concludes our EDA. We have understood the data, and then we have already drawn insights as well on the data. We have done reprocessing as well. So our final data is finally ready for model building. So this is our data. So this is the data that we are going to build our model on. So let me just do trained list bit first. So before doing model building, I want to divide the data into three parts. So first is test data, second is validation and training data. So I want to divide into train, test, and validation. So let me quickly do that. So let me quickly import SQL. Okay, SQL.model selection. Let me import train test script. Train test script. Okay, I've done that. So let me do a train test script here. Okay, you have done a lot of coding, a lot of scrolling down as required. Okay, finally, now we are here. Let me split it into train and test. Train test split. I want to split my DF full, and then I want to just put around 5% of the data, 5% because the number of rows are very less. So if we split more, then probably data won't be sufficient for training. But again, if you don't split into train test, we will never know whether data is actually overfit or underfit or what exactly is happening in to our data. So this is essential. Okay. So this is how the data is. And if you want to replicate the results, so let me just say random check. Let me just put 10. Okay. If you want to replicate the results. So this is the data. And then now I want to test it whether I want to check whether my test data has any target test of my target has any values which are 1. I want to check it. Value counts. Okay. So yeah, guys, there are 96 values which are actually having 1. So this is good enough for me. So I've checked it. So now I want to check the same for my train data as well. Train, target, and value counts. So here we already understood that this data set is completely imbalanced data set. Just like with every ChurnAnalysis data, this data is also imbalanced. So be it the channels of bank customers, credit card customers, loan defaulters, or telecom churn analysis, anything, the data will be completely imbalanced. So what do we do in this type of data? So let me before leaving test data set, let me quickly convert this into text X and text Y. So let me just say drop off. I want to drop my target value x equals to 1, and this is my text X. I want to separate my independent values and dependent values of target. So yeah, I've done that. So let me once this is done, so let's focus on train DF. So this train, it is completely imbalanced. So what do we do now? So we'll say I want to there is a method called as smart. So let us import smart. This particular package is there in IMB learn. So let me say import IMB. I'm not sure if IMB learn is there or not. IMB learn. Okay, as expected, this particular module is not there in my Jupyter. So let me quickly do it. Install IMB learn. There's a method called as smart. So that is what we are going to use now. Okay, so I've imported. I've actually we got an error, permission error. Okay, I'm not sure whether it is imported or not. Okay, So we got permission as well. So let me just quickly, where is my Anaconda prompt? Yeah, another administrator. So let me pause the video, guys, because it is actually taking time to open. Okay, guys, I've installed. All I did is, I've opened Anaconda prompt as administrator and then install. So if you get any errors like permission denied error, this is one way to do it. Okay, still there is some sort of decision. This is some unwanted problem that we are getting it. So what we have to do is we have to uninstall sklearn and reinstall sklearn. With uninstall. Okay, guys. So what exactly happened there is that my sklearn scikit-learn was giving me an error because of the version conflict. So all I had to do was uninstall. So uninstall using this particular command, pip uninstall -p scikit-learn, and then I reinstalled it. And while doing it, it did not allow me to do so because my Jupyter was running and I was using scikit-learn. So it did not allow me. So I had to stop my Jupyter notebook and then uninstall and reinstall it. So once that is done, I was able to let me close this window. I was able to import my IMD learn. So let me do it again for the sake of recording. So what I've done is I want to import smart, which is there in IMD learn oversampling, import smart. Okay. And there are other things like smart EN and ENC. They are for categorical variables. So let me do it for everything we have converted all our categorical variables into numerical variables using one-hot encoding. So we don't have to do that. So here I imported smart. Okay. So let's go back. Let's go down, down and down. Okay. So we already dealt with train test data. So we have to deal with train data now. So I want to oversample. I want to oversample my train data. So the data is completely imbalanced, so less than 5%. So I want to do oversampling of my particular data. So if data is too huge, if it is into millions and the number of churn values itself is into let's say 0.2, 0.3 million, then you can undersample the values as well. But here I want to oversample. And how do we do it? If we create a object saying oversample equals to, I want to say smart, smart, and then I'll say my train x, comma, train y equals to my oversample dot fit underscore resample. I'll say my train df dot, I want to drop my target variable, right? Drop my target variable access equals to 1 because we have done it only for test data, guys. We have done it this only for test data. For train data, we did not do it. So let me just put train df of target. Okay. So let us look at the shape as well after doing it. Okay. So this what we got. So here you can see that we have oversampled this particular one. This 1602. We have made it 6,000, 64,008. So if you want to replicate the results, let me just say random share equals to 10 again. So if you want to replicate the results, so you can do that. Don't forget to add random share equals to 10 there. Okay. So here it is. So now I want to split this one. This split the train and test, train data into train and validation. So how do we do it? Just like how we have done earlier. So let me just say train X and validation X this time, and train Y, validation Y equals train test split. Train test split. I want to split my train X and the oversample data. The oversample data. And this time, because the data is huge, I can actually say a test is equals to, I can say 10%. And then let me say random state equals to 10 again. So let us check the shape of these values also. Okay, let me run it. Okay, here we are. So we got this one. So because the data is huge, we can actually go for test size of 20 as well. So let me just say 20 or 25, because I don't want it to take much more time. So if you want much more accuracy, then probably you can say, like, 20, 25, everything. But here, for the sake of simplicity, I want to work on the as much less data as possible. So let me just say 20, 25 is like an overkill. Oh, okay. I've been splitting the same. Okay, my train here. So because I'm using train X train Y here, and once I split it, I'm doing train to split again on this. So yeah. So let me just say this one. So I want to work on this particular data set. Like, 25% of my oversample data is my test set, which is validation. The rest everything is my train. So okay, guys, this is everything that we have to do before going for module building. So now let me start with logistic regression. So let me just say my sklearn dot query is logistic regression linear model import logistic regression. Okay, let me just say LR equals to logistic regression. Let me create a variable for it, my object, and then say LR dot fit of train X and train Y. Okay. Okay, so this error it is because of the default solver is LGBS, so that is the reason we got this particular warning. But again, you can ignore this particular warning. It's not much. So let me just say predict LR dot predict of my train X, predict of my train X. These are my predictions, and I want to check my accuracy. So how do we check accuracy? So let me import everything, my accuracy score, precision, recall, everything. So let me go back. Okay. So from sklearn dot metrics import, let me say accuracy score, precision score, and recall, and F1 score, and then confusion matrix as well. So let me import everything. So now let me zoom back so that I can, yeah. Okay. So now I want to check my accuracy. I want to check my accuracy. This is training accuracy. So I'll say my original is train Y and then train threads. Okay, I got an accuracy of 91.3%. Let me check precision as well. The precision score of precision. Okay, let me do the same thing for my recall as well. Recall score. Recall is 89. Okay, not bad. And then I want to check F1 as well. F1 score. Okay, F1 is 91, which is pretty good actually. And lastly, confusion matrix. Confusion matrix. So here, confusion matrix is something we should have looked at first. But again, so we got pretty good results, guys. So for something that we have done in less than 1 hour or 2 hours, results are pretty good. Okay, so let us check the same for validation. So for validation data, for val threads, I'll say LR dot predict of my val underscore x. Okay, and then let me instead of doing everything like an accuracy and everything, checking everything, so let me do one thing. Let me define metric, a function which takes original, orig, and red, and it prints everything. Print just a confusion matrix, confusion matrix. Okay, let me just do /n. Okay, and then let me just say accuracy is something percentage. This percentage, yeah, not format. Accuracy score of orig, comma, threads. And if I want to, instead of long float value, if I want to round it off and express it as percentage, I'll say star 100 and then comma 2 Oh, no closing bracket. Yeah. So let me do the same thing for precision recall F1 as well. Precision recall F1 score. Here again, precision recall F1 score. Okay. And confusion matrix, I want to print confusion matrix. Print of confusion matrix, right? There's confusion matrix of reach and yeah. So now I want to check something is wrong. Okay. Okay. I want to check my validation accuracy. So I'll say val press equals to LR dot predict of my validation X, and then I'll say my metric. My original is val Y, and my predicted value is val press. So here, okay, for validation also, more or less we got the same thing between 91.29%, 93, 89, and 91. So this is good. So let us do the same thing for test value also, test data. Test data is very important because that is something that we have not trained our data. Our model hasn't seen the data at all. So yeah, so let me just say test press Vella dot predict as a test X. And then let me just say metric of X underscore Y, comma, test threads. Okay guys, here. So this is the reason why we have to always pick our test data and train data and put it separate. So here accuracy is pretty high. Again, very good. Recovery is also pretty high. But precision, look at precision and look at F1 score. These values are low. These values are low. So that is the reason it's always important to actually separate our test results and our validation. So whenever we train our models, it is important that we first put some test data aside and then train it on train data and then check it on validation data. But finally, the decision should be made on which model to be used on always on test data itself. On always on test data itself. So guys, so this is what logistic regression is. So let us do the same thing for just a random forest. So let me do learn dot ensemble model. So random forest classifier. Okay. Let me just say RFC equals to random forest classifier. So for now, for this particular video, I'm not doing any hyperparametric tuning. So that is something that is expected that everybody knows it. RFC dot fit of train X and train Y. Okay. So random forest actually takes a little time. So if you actually want to see how much time it takes, you can actually say percentage time. It actually gives the time it took to train random forest. Okay. The time is around 4 seconds. Okay. So I want to check my train results. Train press equals to RFC dot predict on train data. Not just this one, but I want my test and validation as well. So let me just say val threads test threads, or and let me also say RF because it is random forest. Okay, and then this is on. Sorry, this should be on texture, and this is on validation. Okay, I got this result. So let me just say metric of my train Y, comma train pairs RF, and metric of val Y, comma metric of here test Y and this one. So okay. So yeah, here train results is outstanding actually F1 of 98 and close to 100. But yeah, here, this is what is our interest. So earlier for logistic regression, it was 58. But random forest gave 64 straight away without any parameter tuning. Okay, let's do the same thing for, let me just say light GBM. Okay, import light GBM. Not sure if I have it. LGB. Okay, I don't have it. So let me open my Anaconda prompt again. Just pick install light GBM. This should be fairly fast. Yeah, this is over. So let me import light GBM. Okay. So my LGB model equals to LGB dot light GBM classifier. Okay. Let me train it. So sorry, train LGB model dot fit of train X and train Y. This is fairly quick actually. So, okay, let me do the same thing here. So here instead of RF it is LGB, right GBM. Okay, okay, we got this. So let's check the results. Okay, so here are the results, and for test it is 62. So as good as random forest, little varying actually. So these are our models, right? So this is where our accuracy is pretty high. So on over 90%. For random forest, it is almost like 95% to 98%. So accuracy is pretty high as expected. And recall, which is most important in churn analysis, this is also pretty high. And F1 score is also acceptable, reasonably acceptable. So what can be done is we can actually stack. So I'll give a quick example of how do we do stacking. So just say like dear. So how do you do? So for if I want to do it for test data, so if I do like test underscore my dear dot head. So here is everything. So we have everything, value unbuilt target, everything. So if I want to check like test data of logistic regression threads equals to what is the value that we gave? It is I guess test threads, test underscore threads. So that is for logistic regression. So RF threads and LGB threads. So underscore RF and then underscore LGB. So let me add these two. So if I do test of head again, all these values, you can see it here. So all these values. Okay. So let us quickly do like calculate metric again. So uh, final. So let me just say final thread. Because let me add these three. Actually, in fact, we may not add these three values. We could have directly done this addition without creating new columns as well. So whatever I'm doing is called as stacking. Okay, and if I say testdf of my final thread goes to np dot where if this is greater than 2, I'll say 1 or 0. Okay, let me do metrics as well. Metric of where do I have down? So my original is sorry, target and then my final thread. This is stacking, the value of stacking. Okay, so see, simple stacking of three algorithms has resulted in my increase to 69%. So my F1 has increased, like, earlier it was 62 for light GPM, and then, for random forest it was 64, and then for large distribution it's 58. 58, 64, and 62 has actually given me 69. So this is the power of stacking, guys. So what I've done is, I've added all these three, and if at least two of these three models say it is churn, then I'm saying churn. Otherwise, it is not churn. So this is what I did, and then these are the results that we got. So simple stacking, and what can be done is hyperparameter tuning and validation as well. So here it is a little, overfit, I would say. So how do we do the cross validation, and then we have CVs actually. So this cross validation of the results, and then how do we have a parameter tune, and then we have grid search everything. So these things can be tried on this particular data as well. So try out all these things method, different methods, hyperparameter tuning, and then probably grid search on for hyperparameter tuning, and then cross validation to avoid overfitting, and then try to see that it comes to around at least like 75%. F1 of 75%, that should be good because accuracy is pretty high anyway, and recall and precision are also good. So any score of above 75 for F1 score is pretty good for these particular kind of use cases. So this is how the projects are done in the industry, guys. So we start with PDA, and then we try to derive insights which are helpful, which businesses have to take some action upon. So in this particular case, whenever the biggest action that we said is if somebody calls customer care, then the chances of they churning out is pretty high. And if the consumption and if the value unbilled is also high over a particular limit, then also the chances of leaving are pretty high. So for unbilled days, there is no insight, so we don't have to predict it. So after insights, what we have done is we went for pre-processing of the data. So we looked at missing value analysis, then outliers for numerical data, then converting it into normal distribution, and then converting everything to same scale. That is something that we have done for numeric values. For categorical columns, we have one hot encoded it. We did missing value analysis, and the missing value analysis we have done it using business project, not with something the rules that we usually learn. So that doesn't apply in real world usually. So domain knowledge is very important. That is something that we have seen here, and that is where we have drawn insights as well. So yeah, that is something. And then lastly, we have done one hot encoding, and then the data is completely imbalanced. So we have done data balancing as well. So we have used mod for it, and then we went for train, test, and validation split. We also learned why it is very important to do test validation separately and not just train test split. And finally, the results, and we lastly looked upon the power of stacking of different algorithms. So let's try on different algorithms. We have decision tree, we have XGBoost, backing, boosting, ADA boost, cat boost. Cat boost might actually give better results because we have a lot of categorical variables. So try cat boost. And you can also try neural networks, but neural networks, because the data is very less, it might tend to overfit. So the number of data records is very less, 30,000 all. So yeah, with more data and trying with more different algorithms, we can actually better the results. So guys, so once again, if you want to get the data, reach out to us. We'll mail you the data, and we won't be charging you anything for this. So we'll give you the data for free. So please reach out to us if you want the data, if you want to practice. And this is a real time data. So don't think this is something that we have generated. This is a real time data. Only thing is we have actually took a sample so that we can actually do. If we try to do the data on full data, build models of full data, we probably have to wait for half an hour, 45 minutes just for model to get trained completely. So to avoid all the waiting period and everything, we took a sample of 35,000 records. So please reach out to us for the sample data. And yeah, try it on your own. Then you can probably put this particular product in your resume as well. This is the real-time data, and then you can actually give insights as well as showcase everything in your resume. Try it out with the different algorithms, hyperparameter tuning. and cross validation, research, everything, and what are the other new techniques that you have learned. You can actually try it out on this particular data and showcase it. So if you have any other doubts on this particular project or data, you can always reach out to us. So thank you, friends. See you all. Have a good day. Bye.